know how to do trigonometry ratios, you will fail math very badly, and I do not want that. So in this video, I'm going to teach you exactly how to do trigonometry, especially if you're a beginner. I'm going to run you through some fundamental concepts, and then I'm going to show you examples of how you are going to apply these concepts into answering questions during your examinations. So first and foremost, what are trigonometry ratios? So when it comes to trigonometry, it's all about dealing with triangles. So let's say I have a right angle triangle over here. A right angle triangle has a angle over here, and let's call this angle theta. Right? When it comes to trigonometry ratios, there are three sides you need to know. So for every right angle triangle, there will be three sides. There will be three sides, namely the hypotenuse, the opposite, and the adjacent. And how do you know where is what, right? The hypotenuse is always the longest side. So in this case, this will be the hypotenuse. And the opposite will be the side that is opposite theta. So in this case, the opposite side will be here, and the adjacent will be the remaining side here. So whenever it comes to trigonometry, for every right angle triangle, there will always be three sides. So the first step is to always identify where is which side. And once you can identify where is your hypotenuse, opposite, and adjacent, then you can start to use trigonometry ratios to calculate unknown sides, unknown angles in right triangles. So when it comes to trigonometry, there are three trigonometric ratios. And all of them take reference to the theta over here, the angle over there. And these three are your sine, cosine, tangent. Right? And it's always sine theta, cosine theta, tangent theta. So the trigonometric ratio has three different kinds, and they all take reference to the theta. And this theta may be measured in degrees or radians. But most commonly we will use degrees, right? Radians is also possible. 1 radian is 360 degrees. Pi radian is 360 degrees. So 1 radian is 360 divided by pi. And that is it. Now, for sine theta, the trigonometric ratio is O over H. So the length of O over here and the length of H, take O divided by H, the value that you get will be sine theta. For cosine theta, it will be A over H, and for tangent theta, it will be O over A. And these values are the values that you get over here. So assuming we have a right angle triangle over here, this is theta, right? And here I have 3, 4, 5. So the sine theta will be the opposite over the hypotenuse. So sine theta will be 3 over 5. Cosine theta will be 4 over 5. Tangent theta will be 3 over 4. And this is the trigonometric ratios. And how do you remember this? I want you to remember this acronym, right? How do you memorize these ratios? Just remember, toi, ka, so. I believe you have heard of this before, and yes, it works very well. So toi stands for tangent equals to opposite over adjacent. Ka stands for cosine equals to adjacent over hypotenuse. and so stands for sine equals to opposite over hypotenuse. And that is how you pretty much remember the trigonometric ratios. With that being said, this is how you apply them into your questions. So assuming the question gives you this triangle. It's a right angle triangle. Let me just redraw this. It's a right angle triangle and this is your theta over here. 5, 12, 13. Right? So the first thing to do is to identify, okay, where is my 3 sides each? So this is my opposite, this is my longer side, so this is my hypotenuse, and this is my adjacent. So in this case, sine theta will be equals to opposite over hypotenuse, therefore it's 5 over 13. Cosine theta will equals to adjacent over hypotenuse, and therefore it will be 12 over 13. Tangent theta will be O over A, which is 5 over 12. And these are my trigonometric ratios. And in fact, using these 3 trigonometric ratios, right, this is how you can work backwards to figure out what is your theta. So in this case, theta will equals to sine inverse 5 over 13. Theta will equals to sine inverse 12 over 13. And theta will equals to, cosine theta. Tangent inverse 5 over 12. And these 3 values will be exactly the same because your theta remains the same. The value of your theta does not change at all. Now, let me just give you another example. Assuming we have this over here. This is a right angle triangle. This is your theta. This is your opposite, hypotenuse, adjacent, right? And now the question says, given that sine theta is 3 over 4, find out what is O, A, and H. So since sine theta is 3 over 4, that means the 3 represents the opposite, the 4 represents the hypotenuse. So O equals to 3 and H equals to 4. So how do we find what is A then? Right, this brings in the concept of Pythagoras theorem. Because we are dealing with right angle triangles, and since this is a right angle triangle, we will have A square plus B square is C square, where A in this case is the big A over here plus the B is the O over here equals to the H squared. And therefore, A square plus 3 square is 4 square. A square plus 9 equals to 16. A square is 16 minus 9. A square is 7. And therefore, A is square root 7 plus minus 7, which means it's either 7 or negative square root 7. But this is rejected as A is bigger than 0. And that is true because A is a length, right? A is a length, therefore it has to be positive. It can't be negative. And that is how you use trigonometric ratios, which is your tua kaso over here, to calculate unknown sides. And you can also calculate unknown angles using this over here. Right, just take the sine inverse or cosine inverse or tangent inverse with whatever you're dealing with to find the unknown angle. So that is the first concept for this, and now we will talk about your second point, which is dealing with sine. That means finding sine, cosine, tangent of obtuse reflex angles. So consider this coordinate, y-axis coordinate over here. Let's call this quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, let's say we have a right angle triangle in quadrant 1. This is your theta, this is your opposite, hypotenuse, adjacent. No problem. And in this Q1 over here, your sine theta will equals to opposite over hypotenuse. Your cosine theta will equals to adjacent over hypotenuse, and your tangent theta will equals to opposite over adjacent. And in quadrant 1, all of these will be positive. The values of your trigonometric ratios will all be positive. And now consider this over here. So now assuming we are in the second quadrant, so this is your theta over here. And how do we find your theta in this case? Right? We cannot just take it as it is and pretty much try to find the trigonometric ratio of theta in the second quadrant, because this is not a acute angle. So what we need to do is to find out what is this angle and minus it away. And let's call this angle the basic angle. So for the basic angle over here, this is your opposite, hypotenuse, and adjacent. And take note, now adjacent is negative, right? Because this is part of the negative x on the number line. It's already negative. It's behind 0. So in this case, sine, cosine, theta, and tangent theta. O over h, A over h, and O over A. Now, this shall not be theta anymore. It shall be basic angle. So since A is negative, that means these two, the trigonometric ratios will be negative, and this will be positive. So only in Q2 will you be able to find that sine theta equals to sine theta, sine basic angle, and cosine theta equals to negative cosine basic angle, and tangent theta equals to negative tangent theta basic angle, because these two are negative. Likewise for Q3, assuming now we have another line over here, and this line extends from here, from here all the way until here. So this is your theta, and in order to find what your theta is, we need to find what is this basic angle over here. And this basic angle over here is your opposite, hypotenuse, adjacent. And now both your adjacent and opposite are negative, and therefore sine, cosine, theta, and tangent equals to O over h, A over h, O over A. And since O and A are negative, this will be positive, this will be negative, this will be negative. And therefore in Q3, your sine theta equals to negative sine this, cosine this equals to negative cosine basic angle, and tangent theta equals to tangent basic angle, because tangent basic angle is positive in Q3. And in Q4 over here, let's just draw this in another color. in order to find what is this, we need to find what is this basic angle. And in this case, only your opposite is negative. This is positive, and h will always be positive. And therefore, in quadrant 4, sine, cosine, tangent, for your sine, it will be negative. For your cosine, it will be positive. And your tangent, it will be negative. And therefore, in Q4, over here, sine theta equals to negative sine basic angle. Cosine theta is cosine basic angle. And tangent theta equals to negative tangent basic angle. And this is exactly how you use trigonometric ratios to find the unknown sides, unknown angles in right triangles of acute, obtuse, reflex angles. And I hope this video has been helpful for you in terms of breaking it down. If you like to learn exactly how to use these trigonometric ratios to solve questions involving sine rule and cosine rule, you can go ahead and click on the video on the right over here. If not, thanks for watching. If you like more support from me and more resources, go ahead and check out the link in my description. If not, thank you for watching. I'll see you in the next video.